Good morning, everybody. Today we are going to continue with circles. It's very possible we'll be working with circles until the end of the year. A couple more weeks we've got, but we're going to talk about circles. We're going to work with tangents today. So we're going to go over a couple of properties with tangents. We're going to do some of the examples together, and then you guys are going to do all of the examples that are circled for homework, okay? All right, so first off, a tangent line is a line that intersects a circle at exactly one point, which is called the point of tangency. So in this case, all right, we have AB is the tangent. AB is a tangent, okay? It's a line, it intersects the circle at exactly one point, and A is the point of tangency. Okay? All right, so first property, a line is tangent to a circle if and only if it is perpendicular to a radius that is drawn out to the point of tangency. So in this case, okay, so a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So the big takeaway here is we've got our tangent line AB and we've got our radius PA. We have AB is perpendicular to PA, okay? And then it's marked by that little right angle box right there. Okay, so first set of directions, we're asked to determine if AB is tangent to circle P. So we need to figure out, is AB tangent or is it perpendicular to that radius? So is AB perpendicular to PA? And the way we can do that is we can essentially say, is this a right triangle? Is triangle PAB a right triangle? And then ultimately, the way we could figure that out when we have all three sides labeled in our triangle is, does a squared plus b squared equal c squared? And that's all you're going to do. We're going to plug in our a, our b, and our c, and we're going to see if it fits into that equation, a squared plus b squared equals c squared. Okay, so remember, C is always the hypotenuse. It's the longest side of the triangle. So we need to check, does 8 squared plus 15 squared equal 17 squared? When we square this, we've got 64 plus 225, 289, and then indeed we get 289 is equal to 289. Okay, so since PA is perpendicular to AB, AB is a tangent. All right, so if it's asking you to prove if a line is tangent, you're essentially checking to see, does the triangle fit into the category of a squared plus b squared equals c squared? So let's try number 2. Now, number 2, you've got to be careful because if you notice, we don't have the whole length of one of our sides of the triangle. We have part of PB is 5, but we don't have the whole thing. So you need to recognize this is a radius, this is a radius. What do we know about all radii in a circle? They are the same. That would be 11. Therefore, our longest side in this triangle is 16. So now we have 11 squared plus 14 squared equals 16 squared, and we have to see if that works out. So 11 squared is 121, 14 squared is 196, and 16 squared is 256. I already can tell that this is not going to work out because 196 plus 121 is much bigger than 256. But we get 317 is not equal to 256. So that means this is not a right triangle. Angle A is not a right angle BA is not perpendicular to PA. So this is not a tangent line. AB is not tangent. Okay? All right. Now, in the next group of problems, it says if JK is tangent to the circle, find X. So now the directions are telling us JK is a tangent. So in all of these problems, I know JK is tangent, therefore I can put my right angle marking, okay? So we can still use Pythagorean theorem to solve for the missing part. So we are looking for the hypotenuse in this problem. We have 7 squared plus x squared equals 19 squared. 49 plus x squared equals 361. Subtract 49 from both sides. X squared equals 312. And then taking the square root of both sides, we get about 17.7. And you can just round to the nearest tenth for these. Okay? I'm going to skip the circled ones because you guys are going to try those on your own. All right, number 5. We've got 10, we've got 24, but we can see that we do not have part of our longest side labeled. This longest side is 10, okay? So we have x plus 10. All right, now this one's going to be a little bit tricky. We're going to need to dig deep into those algebra skills that you guys have from last year. And that's because when we go to set this up, we have our shorter sides are 10 and 24. 10 squared plus 24 squared equals, but then our hypotenuse is x plus 10. Okay, so you need to square x plus 10. All right, so we have 100 plus, let's see, 24 squared is 576 equals, all right, I'm going to do this down here. So when you're squaring x plus 10, you're multiplying x plus 10 times x plus 10. That doesn't mean it's x squared plus 10 squared. That's not correct, okay? You can use the FOIL method, which I'm sure you probably learned in algebra, or you can use the algebra tiles method. So FOIL means first, outer, inner, and last. So first means you multiply the first terms together. X times x gives me x squared. Outer would be the outside terms. X in the first set, 10 in the second set. That gives me 10x. Inner is the inside terms. 10 times x gives me another 10x. And then the last terms in each set would be 10 times 10, which gives me 100. Now we can combine our like terms. This gives me 20x. So when that's all FOILed, I get x squared plus 20x plus 100, okay? Or you can do something called the algebra tiles method, which I really like when you're multiplying binomials. You make a 2 by 2, 4 boxes. You put x and 10, x and 10. And then it's kind of like some people say it kind of looks like a Punnett square if you're in bio or if you've taken bio before. So this first box, okay, that's where x meets x. X times x is x squared. This box here, okay, on top right corner, is where 10 meets x. 10 times x is 10x. Bottom left is where x meets 10. X times 10 is 10x. And then bottom right is where 10 meets 10. 10 times 10 is 100. And then again, you would just write it out, combining all of your like terms. Okay, so this is from algebra. You did learn this last year. You are expected to know it, okay? If you need a little bit more help with that algebra practice, I will post some additional resources for you. All right, so moving right along. So x plus 10 squared is really equal to x squared plus 20x plus 100. Okay, so let's combine both sides. All right, so to me, this is starting to look like we're going to have a quadratic. And in order to solve a quadratic, it needs to be set equal to 0, and you need to be able to factor it. Okay, so I'm going to subtract 676 from both sides. And I have 0 equals x squared plus 20x minus 576. All right, so now we need to factor this, okay? And again, I'm gonna do the work down here so you can see. I'll do it in a different color. All right, so we need to factor x squared plus 20x minus 576. So I need to pick two numbers that multiply to my c value, okay? So a times c would be the coefficient of my x squared term, which is 1, and then my c term, which is negative 576, okay? And then my b value is positive 20. So I need to pick two numbers that multiply to negative 576 and add to 20. So multiply to negative 576, add to positive 20. Now, if we're going to multiply to a negative number, that means we need to do x plus a number and x minus a number. Okay? Now, it's very possible that you may have done this a little bit differently last year. You may have factored by grouping, all right? So if you know how you learned factoring last year, then go with that. All right, 576, that's a pretty big number. All right, so what I like to do is I just use my calculator and I come up with all of the factor pairs. So obviously we have 1 and 576. We have 2 and 288. We have 3 and 192. And ultimately I need to figure out which two of these numbers can somehow add up to 20, making one positive and one negative. We've got 4 and 144. It's not divisible by 5. We've got 6 and 96. All right, let's see. It's not divisible by 7. We've got 8 and 72. We've got 9 and 64. It's not divisible by 10. It's not divisible by 11. We've got 12 and 48. All right, we're getting closer. It's not divisible by 13. It's not divisible by 14. Not divisible by 15. And then we've got 16 and 36. So I'm going to stop there because I'm seeing, all right, if I make 16 negative and 36 positive, when I do negative 16 plus 36, I get positive 20. Okay, so my factors are going to be a negative 16 and a positive 36. All right, so let's bring that back up here. I get 0 equals x minus 16 times x plus 36. Okay, now when you're solving these, I'll go back down. When you're solving, we're going to set each set of parentheses equal to 0. And then in this one, we would just subtract 36. We get x equals negative 36. Over here, we're going to add 16. We get x equals positive 16. So those would be my two possible solutions, okay? So in algebra, you would say that those are your two solutions, 16 and negative 36. In geometry, we have to be careful because it doesn't make sense to have a negative side length, okay? We can't have a negative 36 as a length. It doesn't make sense. So that's what we call an extraneous solution. We don't choose that solution. We only choose the positive one, okay? I know that was a lot of work and it was a little tricky. There won't be too many like that, but you may have to factor like so. All right, let's move on to number 8. All right, so we've got number 8. We don't know what all of MJ is. Right now, only LJ is labeled, but LJ is a radius, and that equals X. Okay, that means JM is a diameter. We just multiply the radius by 2, and it's 2X. So this right here is 2X. So now, our longest side is the side that's across from the right angle, so that would be 25. That's our C value. So we have 7 squared plus 2x squared equals 25 squared. And you notice I put my 2x in parentheses, and that's because when you square 2x, you're squaring the 2 and the x. So 49 plus 4x squared equals 25 squared is 625. Okay, I'm not going to have to factor this, right? We're not going to have to do that. We can just solve by getting x by itself. The only reason I knew I had to factor this one over here is because I had an x squared term, an x term, and a whole number term. Okay, but this one we only have an x squared term, so we don't have to worry about factoring. So I'm going to subtract 49 from both sides. I get 4x squared equals 576. That's just a coincidence that we see 576 both times. I'm going to divide by 4. We get 144. And then I'm going to take the square root of both sides, and we get x equals 12. Okay? All right, so that one, still a little bit of algebra work, not as bad as having to factor. It looks like you're not going to have to factor any of the ones circled on this page, okay? You'll have to take square roots, much like we did with number 8, but you won't have to factor like we did in number 5. Okay? And anything like number 5 would be extra credit on a graded assignment. I'm not going to give you something like that and make it count for credit. It would just be some kind of extra credit question. So don't panic. Don't go into full-blown panic mode if you're having trouble with the algebra aspect of it. That would just be extra credit. All right, let's flip to the next page. Okay, so I'm going to have you guys try number 9 on your own. Okay, and again, number 9 is going to be more like where we did with the one that you have to factor, because we know that radii are congruent. All right, so this would be x, and this side would be x plus 10. Okay, so I'll set it up for you, but then I want you to actually try it. So our shorter sides are x squared plus 20 squared equals x plus 10 squared, okay? And then actually, looking at this one, you won't have to do the full-blown factoring. After you FOIL, you'll see why. And remember, you already have this from the other side, so you can just look at the other side and you can get it from the other side, okay? So we would end up having x squared plus 20x plus 100. All right, and I'm going to stop there, and you're going to finish the rest of it. Okay, but you'll notice you have x squareds on both sides. They'll end up canceling each other out. You won't have to factor. Okay, let's move on to our last 2 properties for the day. I'll do 2 more examples, and then you guys will be doing the rest on your own. So more tangent line properties. If 2 segments from the same external point are tangent to a circle, then they are congruent. Okay, this kind of looks like a party hat. This is something called the party hat theorem. Because if you look at number 11 especially, it looks like a little guy wearing a party hat at a party, okay? So when you see this party hat, the sides of the party hat are congruent to each other. So, for example, in number 10, okay, assume that the segments that appear to be tangent are tangent. AB and CB are both tangent lines that come from the same point B. Therefore, AB is equal to CB. So we just set these equal to each other. And and we do our nice little solving for x. So we get 23 equals 3x minus 19. I'm going to add 19 to both sides. We get x equals 14. And they just wanted us to solve for x, so we don't have to plug back in. Okay? You're going to try number 11, but pay attention. They're asking you to find PQ, so make sure you plug back in after you solve. All right, let's look at number 12. Number 12 is asking us to find SV. So let me highlight that real quick. We're still going to use this idea of the party hat theorem. It's just going to be a little bit longer before we get our final answer. So I know that ST and SU are congruent because they are two tangents that come from point S. So that's the first thing we're going to do. We're going to solve for x. And just go about your normal business of solving for a variable in a linear equation. And we get x equals 8, okay? But they're not asking us to find that. They're asking us to find SV. So I think our next order of business would probably be to plug in. And remember, these triangles are the exact same, so I'm just going to choose to use this one because I already have two parts labeled. Here's my right angle, okay? I'm going to plug back into ST. So we get 10 times 8, which is 80, and 80 minus 41 is going to give me 39. Okay, all right, so now let me redraw that triangle. We've got 17, we've got 39, and they're asking us to find that hypotenuse. So now what do? You've got it, we do Pythagorean theorem. 17 squared plus 39 squared equals x squared. All right, 17 squared is 289. 39 squared, that's going to be a big one, 1521. We get 1810 equals x squared, and then I'm going to take the square root of both sides. And I get about 42.5. So the length of that segment is about 42.5. Okay? All right, last problem we're going to do together is number 14. And the last property that we need to talk about, if a polygon is circumscribed around a circle, then all sides are congruent. Okay, so circumscribed means that the polygon, each side of the polygon is a tangent line. So that means BA is a tangent line, BC is a tangent line, and AC is a tangent line, okay? Now, remember, two tangent lines that are coming from the same point are congruent, but only up to that point of tangency, okay? So, for example, this little piece is congruent to this little piece. So this little piece right here is 23, okay? This little piece is congruent to this little piece. So this little piece right here is 27.1. All right. Now I need to find that little piece and that little piece because I don't have them labeled. Okay. So to find this little one over here, this top one by Q, I know that it's congruent to that one. And in order to find the other part of Q, I could just do 37.5 minus 23. And that gives me 14.5. Okay. And now, to find this little one over here by S, I could do 52.5 minus 27.1, which gives me 25.4. Okay, so now let's kind of go back and look at what we have. I need to use the entire side length of each one to find the perimeter. So even though this is labeled, I'm just going to relabel it so it's easier to see. So we know that that whole one is 37.5. So in theory, I don't really need this 23 right there, okay? Because I already know the whole thing is 37.5. This one PS, we need to add 23 and 25.4. That gives me 48.4. Okay, I already know that this one is 52.5. So I can kind of get rid of that. Okay, so in theory, I don't need this 27.1. And now the last side I need to calculate would be QR, which is 14.5 plus 27.1. And that gives me 41.6. So now to find the perimeter, I'm just going to add all those sides together. Perimeter equals 37.5 plus 41.6 plus 52.5 plus 48.4. And we get a perimeter of 180. Okay, now that doesn't mean 180 degrees. It has nothing to do with a circle or a half circle or a triangle. That is just a coincidence that when we added all those sides up, it was 180. It could have been 297. It could have been 17. It could have been any number. It was just a coincidence that that was 180. Okay, so you guys are going to go ahead and finish the problems we haven't done. So you've got 9, 11, and 13 on the back. And then on the front, you've got 4, 6, and 7. So you have 6 problems. Finish those up. If you want to do them on a separate sheet of paper and submit that separate sheet, that's fine. If you want to do it right on this sheet of paper along with the notes and then submit that, that is fine as well. And then you guys can just submit it as a nice, clear PDF. If you have any questions, just email me. Let me know. Have a good day.